So, Peter, I've been wondering how Discord handles voice chat for millions of users simultaneously. What's their overall architecture approach?
With Stewie, Discord uses client-server networking instead of peer-to-peer. So instead of everyone connecting directly to each other like a big mess of phone calls, everyone connects to Discord servers which act like operators routing the calls. This works way better for large groups because they've seen 1,000 people in one voice channel.
That makes sense, and I assume they use WebRTC for the real-time communication, but how do they handle different platforms?
Yeah, WebRTC handles real-time audio and video, but they built their own custom C++ engine for desktop and mobile. This lets them do stuff like bypassing Windows auto-ducking, which is when it lowers game volume during calls, and they added custom voice detection to know when you're actually speaking.
Interesting. What about the initial connection setup? How do clients figure out how to connect?
In their native apps, they skip the usual negotiation. Session description protocol is normally how devices exchange all their connection info, but it's like 10 kilobytes of data. Instead, they use a lower-level API and only send the essential server address, encryption keys, codec info, and stream ID, about 1,000 bytes total.
What about security? How do they encrypt the audio data?
For native apps, they use SLSA 20 encryption instead of the usual web protocols. Normally, you'd use Datagram Transport Layer Security and Secure Real-Time Transport Protocol DTLS and SRTP, but SLSA 20 is faster. They also do silent suppression, so they stop sending data when you're quiet, which saves tons of bandwidth.
What about their backend? How do they decide which voice server to use?
They have 3 main services written in Elixir: Discord Gateway, Discord Guilds, and Discord Voice. The Guild server watches their service discovery system called Etseri to find the least loaded voice server in your region. All voice channels in a guild use the same voice server to keep things simple.
And how does the actual media routing work with hundreds of users?
They built their own selective forwarding unit in C++. MITES and SFU basically forwards audio and video between users efficiently instead of sending everything to everyone. It handles server muting by dropping packets, bridges between native and browser apps, and processes reports for video quality optimization.
What happens during server failures or attacks?
When a voice server fails or gets hit with a DDoS attack, it gets removed from the service discovery system. The Guild server assigns a new one, pushes all the voice state objects over, and clients reconnect automatically. Pretty seamless for users.